Hello and welcome to another packet tracer video with Edgar. In this video I'm going to work with a spanning tree protocol. We got in this topology three switches. I put the MAC address of each one to see more clearly what's going on. So the first step to know who is the root bridge for this topology is to look at for the priority. If we got the default priority for each switch, then we need to compare the MAC address and look for the lowest and read for left to right. So I'm going to cable in this using straight to cables. We want to work with only VLAN 1 for now because I don't set up the trunking and allow any VLAN than the default. So we need to wait the port states that we know in the last video. So we need to wait for the blocking, listening, learning, and forwarding mode. And as we know, I cable in this with fast Ethernet ports. So fast Ethernet cost the link 19. So we're gonna put that for documentation. Okay, gonna copy paste this because all the links cost the same 19. So if we have all the switches with a different priority, then we need to look for the lowest MAC address. And reading for the left to right, we got SW1 has 000, SW3 003, sorry, SW2 003, and SW3 00D. So we need to know the D mean in hex number. So the D is 13 for the decimal number, and we know that 13 is higher than 3 and 3 is higher than 0. So by now we know that SW1 is the root bridge for this topology. To verify which are the root bridge using commands, which you need to know, we need to know the command to do this is show spanning tree VLAN 1, because if we don't put the VLAN 1 and we have more than one VLAN in the SW1, we will see all the VLANs for all the spanning tree. So I'm going to make a filter for the spanning tree information to show only VLAN 1. So by put this, I got the VLAN ID, the spanning tree protocol that is IEEE. So all the Cisco switches by default run PVST for VLAN spanning tree protocol. That's the that's the proprietary by Cisco, enhanced for the standard STP. The default priority is 32769 because we need to assume the default VLAN, which is 1. And we got the address for the MAC address, and this information, it's about the root bridge. The first information, the root ID, is about the root bridge, and the bridge ID is about the local switch. So if we compare the MAC address for the root ID and the bridge ID, we see is the same because this is the root bridge. Is the root bridge because all the switches has the default priority, and if we got this default priority, then we need to compare the MAC address, and the MAC address of this switch is lower than any one in this topology. So another way to know who is the root bridge, this is this message. This bridge is the root. So with this information and comparing the MAC address for the root ID and bridge ID, we know this is the root bridge. Another way to know who is the root bridge in this topology is to see at the row and the states. Always the root bridge, the row gonna be in designate and the states is gonna be in forwarding mode. So we got left. Let me put the information. These ports are in designate mode because both ports or any ports connected to the root bridge gonna be forwarding and gonna be designated. So we got to find out who is the root port, The root port by the terminology is the port to has the lowest path to the root bridge. In this case, we don't have any switch in the middle, so we know that the lowest cost for SW3 is this link, the F1. So by this, we know for SW3 the root port is F1, and for SW2 F12 also is the root port. We can check this by using the same command, show spanning tree VLAN1, and we see F1 is the root port and is in forwarding mode. The cost is 19 because we're using a fast internet interfaces. So I'm going to put that information is the root port, and this is the root port 2 because we don't have any switch in the middle. So let me share the same information about the SW2, show spanning tree VLAN1, and we see the F1 is the root port and is in forwarding mode and the cost is 19. So we got left select which of two of these switches gonna be forwarding mode and the other blocking, because we need some link to be blocking, because that's the purpose of STP, to prevent loops. So we need to put one of the links in block to prevent a block storm or a infinity loop or a MAC collision. Okay, if we the first question is, like we know, I need to look for the priority. If the priority are the same, then we need to look for the MAC. 003 is low than 00D because D is 13. So that's the reason, because SW2 is the F23 port is designated forwarding. So we know that this port is designated forwarding, and copy that for this D. And the left port we have is the F1 of in SW3, which the port is the F2, which the port is alternate blocking. So we got the same cost because we are using the same links. We compare all the information with MAC because all the switches has the same priority. So how about if I put the SW3 to be a root bridge? Let's do that to see what's going on. Conf T, the command to change the priority is spanning tree VLAN1, because we need to choose the VLAN we want to affect, because PVST is per VLAN spanning tree. We can use different we can assign different switches to be the root bridge for different VLANs. So spanning tree VLAN1, and I'm going to use iOS help, and we have two commands, priority or root. Priority is to set up the switch by a number increasing by 4096, and root is a command that we can use to put SW3 like a primary root, and the root will find out which has the lowest priority, and then put in the SW3 a lowest one, lower than the root bridge in the moment. So I'm going to use priority by now. Priority, and the counting is 4096. So if I don't know that kind of information, I can use how can I say, a unpaired number. So I'm going to put 5, and the iOS is more intelligent than us and give us the allowed values for the priority. So if we know the default priority is 32768, I'm going to use 8192. To do that, I'm going to put the same command, spanning tree VLAN1 priority. I'm going to use the 8192. By this, all the topology with the STA, the spanning tree algorithm, we need to change the states for the links, because the root bridge is not anymore the SW1. It's gonna be the SW3. And if I put on, let me get out of config. If I put show spanning tree VLAN1, we will see the port are in the state of learning, learning, jet. Remember, okay, I got forwarding, so that's the final step for the port states. And remember, spanning tree, the port states takes about 50 seconds to know how to assign. So if you see the green amber change from the 20 for the SW3 to the port going to the SW1. That reason is because if this is the root bridge, the port of the root bridge gonna be in designate forwarding. The port connected to the lowest cost to the root bridge gonna be in root port. So I need to remove all this information. The cost not, because it's the same. So this is designated. This is a root port. This is a designate. This is a root port. And comparing the MAC address for SW2 with SW1, we know that 000 is lowest than 003. So that's the reason, because this is the designate and the blocking mode is this link. So the another way, the last way to know how to change the priority is to using the root, and I'm going to put the SW1 again to be the root bridge. So we know already we have the default priority in SW1 and in SW2, but in SW3 we change manually by using priority numbers, and the priority is 8192 plus 1, which is 93. And the root, we're going to calculate the root bridge and put in SW1 a lower number than the root bridge priority. So spanning tree on SW1, VLAN1, root, primary. With that, all the topology gonna be changed again. So we know this is gonna be a designate, this is gonna be a root port, this is gonna be a blocking port, this is gonna be a designate. Designate this. This is the root port because it's the link with the lowest cost to the root bridge. Root port and blocking mode. So we need to wait for that. Okay, we got left one link on the SW1. And if we check the information, show span, we see the command root primary put the SW1 automatically in 4097, which is lower than 8193. So you have two ways to set up the priority on an STP, or using our STP rapid spanning tree protocol, which is the same, but the way to port states is different because it's discarding when the in STP is disabled, is discarding when it's in blocking in STP, in discarding when it's in listening, is learning when in STP is learning and forwarding. So the RSTP goes from discarding to learning to forwarding. That's the reason the RSTP is more a quick conversions with the calculation about the root bridge. So that's all by now. In the next video, I'm gonna work with advanced spanning tree. We're gonna use two more VLANs, and we're gonna talk about BPDUs, BPDU guard and port fast. See you there.